Okay, I'm going to try to make this a quick review of linear equations and everything that's key. Remember, linear equations or linear functions produce lines that are straight. And you use linear equations for tracking data over 2 dimensions, right? An x and y axis, and you're tracking data. You draw lines between them. The slope is also referred to as the rate of change, or sometimes just the rate. Here's one way to look at it, the rise over run. So if you've got a slope here, I'm in a point here, how far do you go up? That's the rise. How far you go over to the right, that's the run. Then you've got the formula, the second y, subtract the first y, that expression divided by the second x, subtract the first x. When you divide those two, you get a ratio. That ratio produces the slope. And you use this formula when you have 2 points or you have a drawing. Although if you have a drawing, then rise over run is easier. All right, 4 types of slope, and this is as you read left to right. So you start over here and you read this way. So as we read left to right, if we start here, that line is going up, so that slope is positive. And if we start here on the left, going to here, that slope is negative. And then if you start a point here and there, you go neither up nor down, and so that is called a zero slope. And when it's vertical like this, it's called undefined. This is why if you're driving in a car, there's no way you can make that sharp turn. That line is so steep, that slope is so steep, it's undefinable, or it's infinitely steep, but we usually say undefined. Okay. When lines are parallel, the slopes are the same. So y is equal to 2x plus 5, y is equal to 2x minus 3. The graphs would look something like that, parallel lines. When they're perpendicular, the slopes are opposite reciprocal of each other. So if one slope is 2, the next slope is negative 1/2, which is what we have right here. And let me draw the graph of that. So if we've got 5 and we go up 2 over 1, and then we're down here at negative 1, and that slope is down 1 over 2. And then if we keep graphing that, oh, look at that. They intersect perpendicularly. So they are perpendicular lines, and lines that are perpendicular have opposite reciprocal, meaning if this is positive, the next slope is negative, and then the numbers are flipped, are the reciprocal of each other. Then you've got 3 forms. Standard form, ax plus by is equal to c. We usually use these in word problems and not for graphing. But if you wanted, oh, I know I had that. If you want to graph, then find the intercepts. And in order to find the intercept, so if you had 3x plus 4y is equal to 12, set x equal to 0 to figure out what the y-intercept is. Remember, the y-intercept is when x is 0 and you know the y value. X-intercept is when you know the x and the y is equal to 0. So if we set this equal to 0, then you have 4y is equal to 12, divide both sides by 4. So that would be the y-intercept of this equation. And if we found the x-intercept, we'd set y equal to 0. Well, then you'd have 3x is equal to 12, divide both sides by 3, and you get x is equal to 4. So then once you know those things, the y-intercept is 0, 3, the x-intercept is 0, 4, you can go ahead and graph. All right, so when you have a standard equation, use the intercepts rather than taking the time to solve for y is equal to mx plus b. Just set the x value equal to 0 to see where it intersects the y-axis. Set the y value equal to 0, and then draw the line. Okay, slope-intercept, if you have it in y equals mx plus b form, that's used for graphing. You always graph the b, the y-intercept first. So if y is equal to 3x minus 1, minus 1 is the b, so a negative 1, and then you go up 1, 2, 3 over 1. But you always plot the b value first. Okay, then when you have point slope form, that's typically when you're given a point, hence the point. So let's call this 2, 1, and you're told what the slope is. Slope is, say, 2. Well, then you can take this, here's your x1 and your y1, and you can plug it into this equation. So y minus the y1 value, which is 1, our slope is 2, and then x minus the x value, do the distributive. So now you have y minus 1 is equal to 2x subtract 4, and now add 1 to both sides. And now you have it in a form that you can graph. So when you have point slope form, you usually, sometimes you'll just know 2 points, and then you must find slope first, and then just use one of the points. So if we would have had 2, 1, and let's see, what would have another point be? 3, 3, I think is another point. You would take those and find the slope. So 3, the y values, second y subtract the first y, divided by the second x subtract the first x, and you get 2 over 1. So you get the slope of 2. And then you've got those 2 points. And then you can either use 3, 3, or you can use 2, 1 and plug it into point slope form. All right. Systems. There's 3 possibilities. There's a 1 solution, and that's going to be most of the time where 2 lines intersect. That is the solution set. And these type of systems are called consistent and independent. Okay, then you've got a no solution. Parallel lines never intersect, so there'll never be a crossing point. That's called no solution, and that's when lines are parallel. So say y is equal to 2x plus 5 and y is equal to 2x minus 1. They both have the same slope, so this will automatically be a no solution. And these type of equations, or this type of system, is called inconsistent. And then finally, when you have 2 equations and when you solve them both for y, they end up being the exact same thing. So maybe 2x plus 3 and 2x plus 3. They end up sitting right on top of each other. Lines that lay on top of each other have infinite solutions, and sometimes also referred to as all reals. And this system is called consistent and dependent. Okay, then when you're solving systems, you can use the substitution method. Graphing method first. So you graph, and where they intersect, that's the solution set. The substitution method. So if you've got 2 equations and y is equal to 3x, where this y is, we can now substitute and put 3x, which is what we did right there. And then you can solve for x. 2x plus 9x is 11x. Divide both by 11, you get x is 2. And now we can take the 2 and plug it back in here. 3 times 2, the y value will be 6. Just like that. Okay, that's substitution. This is my least favorite. So if at all possible, try to do graphing or elimination. And elimination is when you have the equations in standard form. Ax plus by is equal to c. And then you try to eliminate either the x's or the y's. Now notice on this one, one's a negative 4y, one's a 4y. So you can add the columns and the y's will eliminate. Sometimes you're not so lucky. Sometimes the y's are not opposite. So in this example, the y's are the same, so you use the subtract method. So 3x subtract x is 2x, y subtract y cancels, 21 subtract 9 is 12. Then solve for x, and once you know what x is, you plug x. I would plug it into right there. So 6 plus y is equal to 9. Well, y is equal to 3. Okay, then you may have to multiply one or both rows. In this example right here, since we've got a negative 4y, and this is the x's are both positive, but the y's, one of them are opposites. So I selected to multiply this whole row, both sides, by 4. So I'm going to write that multiplied out down here. So 4x plus 4y is equal to 20. And then I'm going to rewrite the original second equation right there. 3x minus 4y is equal to 8. Now that the y's are opposites, you can add the columns. So the x's add up to 7x. The numbers on the other side, the sums add up to 28. Divide both sides by 7, you get 4. And when you plug the x plus y is equal to 5, if you have 4 plus y is equal to 5, because we can now substitute the x for 4, y is equal to 1. All right? All right, so that's kind of a summary on that. And now we're going to talk about inequalities, just the highlights. So if the inequality arrows is pointing to the left, and you've got the y here and the y here, that means this is saying y is less than or equal. When you graph the line, if there's a solid line here, you graph it with a solid line. If there is a missing solid line, then you graph the line as dashed. And when the arrow is pointing to the right, that's the greater than. Okay? So if we just had an inequality where it was the x-axis and we said x is less than 2, that would be a hollow dot at 2. And that says x are all the values less than 2. So you would shade this way. If this said x is greater than or equal to 5, at 5 you would put a solid dot, and then the values are greater than 5 going to the right. Now when you have linear equations, we're usually now talking about the y-axis that you're looking at. So if where they intersect is 0, 0, going up are the greater values, going down are the less than values. Okay, so we're going to go, and then you shade accordingly. And other teachers will teach how you find where to shade. I'm going to show you the fastest and very reliable. So here you have your y equals mx plus b. The b is -1, but you first note, is that going to be solid or hollow? It's missing the solid line underneath, so a hollow dot at -1, and then that invisible slope is 1. So we're going to go up 1 over 1. I'm going to put a hollow dot, and then I'm just going to go ahead and kind of guess where that would be graphing at. Okay, now look at what the shading says. Whoops, did not mean to do that. all the y values are greater than this expression. So we're going to look right here on the y-axis, and where did we say the y's get bigger above? So you shade above when it's y is less than, or y is greater than. So I'm going to take where that the -1 and the y's get bigger up here. And notice I'm just going to do some vertical lines. I could have done horizontal lines, and I'll show you in a minute why I chose to do that. Okay, and then we're going to graph the next. Now, first thing we notice, there's a solid line, so this will be solid dots and solid lines. Okay, and then when we graph, when we shade, it'll be all the values smaller than y. This y is going to, you're going to shade for all the values less than that expression. So we're going to put a solid dot at +1, then that slope is -2, so now we're going to go down 1, 2 over 1, and then down 2 over 1. Now I'm going to go up 2, back 1. So now I can kind of I did not do that very well. Graph that green line, and now this says less than. So I'm going to put my shading right here. Where are the values smaller than +1? Well, they're down here. They're down below. So now I'm going to make that smaller. So everywhere, and then notice what happens where the lines overlap. They form a hashtag. And so I joke with my students in class, it is so dumb, I know. They form this hashtag. So I would say hashtag solution. It's really dumb. Okay, that's kind of a short version of that. Sometimes the teacher will say, pick a point. If you have just one inequality, and let's say the line looks like this, they'll say pick the origin 0, 0. So let's say this is y is greater than x plus 4. So you pick a value 0, 0 is an easy one that's below it, and pick an easy one above it. So let's call this 0, 8. Well, remember, that's x and this is y, this is x, this is y. So for the y value down here, we're going to put 0 is greater than 0 plus 4. Well, is 0 greater than 4? No, false. So false, you're not going to shade this region. But if we put 0 in for x and 8 in, is 8 larger than 4? Yes. So, and look at that shading above, y is greater, so right there, shading above. That's why my method is a little bit, I think, easy to see visually. All right, good luck with testing.